Welcome to the technical overview of Microtrace's Alerion AI classification technology. In this overview, we explore three key features that surpass the functionality of conventional AI and machine learning classification and provide capabilities not possible with conventional classification. We will describe Microtrace's unique expansion class, which isolates previously unknown samples and provides actionable data. Enhanced targeting, which allows for each class to be uniquely optimized to ensure accurate identification. And warning thresholds that provide meaningful insights into drifting of known samples and the identification of undefined samples approaching defined classes. First, let's compare conventional classification, like machine learning and AI neural networks, with Microtrace's Alerion AI classification technology. In this example, we have a model with three defined classes. The left is an illustration of conventional classification. All classes must be known and trained at the same time. In contrast, Microtrace's Alerion classification individually trains each class as its own model, allowing you to continuously build and add classes. The classes do not need to be known or trained together because Alerion classification utilizes an additional class, the expansion class, to capture unknown samples and adapt. Any sample that doesn't match a predefined class is categorized in the expansion class. This is dramatically different than conventional classification, which force classifies all samples into a pre-trained class. To illustrate this capability, imagine a scenario where samples are collected from detectors or IoT devices and recorded in the AI system. In this scenario, 3 samples belong to a trained class and 4 samples are previously unknown. With conventional classification, we see samples force classified in a predefined class. Once samples are inaccurately classified as either A, B, or C classes, the accuracy of the entire model is compromised. Unknown samples are incorrectly classified into known classes, making the model obsolete. Identifying unknown samples requires a parallel surveillance program, and adding new classes requires building a new model, a limitation of conventional classification. In Microtrace's Alerion classification, unknown samples are isolated within the expansion class and an alert is triggered. As samples are recorded, they are classified into A, B, C, or remain isolated in the expansion class. Patterns in sample data may start to emerge. As they do, they can be identified, grouped, and formed into additional defined classes. This gives Alerion classification the ability to adapt and grow over time, eliminating the uncertainty of starting over. Enhanced targeting allows classes to be refined by adjusting individual thresholds to precisely match incoming sample data, which means your classification system will continuously learn and evolve real-time, resulting in a highly accurate and adaptable AI classification system. Building on the unique concept of enhanced targeting made possible by Alerion classification is the ability to set warning thresholds, which can be added to the inside and outside of any combination of class boundaries. Warning thresholds placed inside the class boundary alert you when a defined sample is drifting from your target range. Warning thresholds placed outside the class boundary alert you when a defined class or undefined sample approaches your target class, which gives you the ability to draw conclusions and take action. Microtrace's Alerion AI classification technology, with additional expansion class for undefined samples, enhanced targeting, and warning thresholds, provides you with a level of accuracy and insight not available with conventional methods.